Now we are going to solve some statistic questions. We are going to deal with the normal distribution. Now the first question is the number of accidents per day at a large factory is noted for each of 64 days with a x bar, the sampling mean, and the standard deviation of the sample as 1.52. The first job is here to take a note n is equal to 64 and x bar is equal to 3.58 and then s is equal to 1.52. Now the standard error for the x bar, which I will use in my formula, is equal to my standard deviation for the sampling divided by square root of n. So in this question, it will be 1.52 divided by square root of 64. And then, with what degree of confidence, so the confidence level is our question. Confidence level is our question. We can assert that the mean number of accidents, so the mean number of accidents per day is between 3.20 and 3.96. So we know that good estimator for population mean is the mean of the sampling or sampling mean. And we know that we say mu is between x bar plus margin of error less than x bar minus margin of error. So the margin of error in this case will be critical z value times standard error of x bar, which is with this formula, s over square root of n. So if I illustrate this, I have a normal distribution and I will have a mu here. So I am wondering that this population mean, how could it be between 3.20 and 3.96. Meanwhile, my estimator is here x bar, if I say, which is, where is it? We said that 3.58. So 3.58. We know that our estimator sampling mean could be regarded as our mu value here for this kind of questions. So to do this, we can find the z-score of 3.20 and 3.96, but now I'm not going to use, I will use directly Normalcdf function on TI-84, and the lower bound 3.20, upper bound 3.96, and the mean is 3.58, and standard error 1.52 divided by square root of 64. So this will be my result. So let me do this by using my calculator here. Second was Normalcdf, and then if I take lower bound 3.20, upper bound 3.96, and then mu is 3.58, and do not forget that our x bar could be regarded as 3.58 since this is our best estimator for the mu, and then standard error 1.52 divided by square root of 64, which is 8, or you can even write square root of 64 like this, and then when we passed. So result will be 0.95449. So when I look at 0.9544, it's clear that by multiplying 100, 95.44, and when I check the alternatives, the result is D. Yeah, that's it. So this area is 0.9544. So the probability of the accidents per day, by using this information, we can say that between 3.20 and 3.96 is 95%. Okay, if we look at the second question, what is a critical t-value for finding the 90% confidence interval for a sample of 15 observation? For the t-value, first of all, we need the degrees of freedom. Degrees of freedom is n-1, which means we have 15 observations, so 15 minus 1, so we will have degrees of freedom 14. So if I draw my critical t-value here, okay, this is my t-value, critical t-value. Since the question says that confidence interval is 90, so it means that here 0.90 here, but when this is 90%, my alpha value, which will be 1 minus 0.90, which will 0.10. So in this tail and in this tail, total I will have 10%. So half of it, if I say 0.05, which is 5%. So totally, the t value here, I have to check t of 0.05 and degrees of freedom is 14. So if I write this in my calculator, so where was it? Second was inverse t, right? Inverse t. When I write it, the area is 0.90 plus 0.05, which is 0.95, 0.95, and degrees of freedom is 14. So the result will be, let's see, 1.761. So the answer is E. So it will be, meanwhile this is 95, right? So it will be 1.761. How did I get this? 5% is here. So the area will be here, the critical t value. So it will be 0.95. So inverse t, the area, which is, we said that 0.95, and degrees of freedom n-1, which is 14. When we say, we got the result 1.761. So this is our critical value. Okay, good. Right now, the 34% of Americans, so there's a proportion here. So there's a one p-value here, which is 0.34. Says that math is the most important subject. So if 34% says this, math is the most important subject, 1 minus p, which is 1 minus 0.34, which is 0.66, right, is now saying that math is not important subject. In a random sample of 400 Americans, so there are 400 Americans, what is the probability that between 30% and 35%, so we are being asked the probability of 30% less than x, our probability distribution variable, 0.35. So this is the question. So what can I do, or what should I do? Now, it's clear that, so we say that our p-value is 0.34, and the question is asking what is the probability is between this. So simply I should find this area. How can I find this area? To find this area, I can use Normalcdf. I can use, let me clean this better, eraser. So I can use Normalcdf, but lower bound is 0.30, upper bound is 0.35. My proportion, which is in the calculator, which could be regarded as the mu, 0.34, comma, I should say here something, and I have to be careful here, the standard deviation. But the standard deviation for this, standard deviation for the proportion, I know that as a formula P times Q over N. So in this case, it will be square root of 0.34 times 0.66 divided by 400. Since N is 400 here, P is who is supporting the idea 0.34 and Q is not. So when I use the calculator, TI here, so let's take it here. First of all, second was Normalcdf. So the lower bound is 0.30, the upper bound is 0.35, and 0.34 is the mu, and then sigma is square root of, where is it? Is this square root of? Yeah, 0.34 times 0.66 divided by 400. So when I passed and entered, result comes out 0.6179. So do I have this result? 0.6179. So if I round it, 618, which is the answer, will be part D, 0.6179. 0.6179. So I can say that this is 0.618. So this will be my result. Okay, good. Now, in a recent international survey, 11% of the 10,000 Americans. Okay, so 11% of 10,000. It means that 11 over 100 times 10,000, which will be 1100 Americans under 50 said that would be willing to implant the device in their brain. So this is now the probability, or p hat if I say, or the p, it's fine since this is the population, 1,100 out of 10,000. So I can easily say that now Q, which is 10,000 minus this, so it will be 8900, right? Their sum will be 819, yeah. Okay, this is the number of people. So now, but I think I need the proportion instead of this. So I can easily say that this is divided by 10,000. So it will be, okay, let's say divided by 10,000 and divided by 10,000. Actually, no need to use this way. Since the 11 is directly given, I can use it for this. So I can directly say that in this question, the p value is given 0.11 and q value, which is 1 minus p, so it will be 1 minus 0.11, so it will be if I subtract 0.89, which are not supporting the idea. So what is the margin of error of the error for the 99 confidence level. So confidence level is 99%. So margin of error is the question. So we should know this one. Margin of error is equal to my critical z value times standard error of my proportion. So here the standard error is, as we done even in the previous question, it will be 0.11 times 0.89 divided by n, which is number of people, 10,000. And what about the z star, which is critical z value? The critical z value we calculate by using the confidence interval. So we said that this interval is 99%, 0.99. So the left here, this totally both of them 1%, and half of the one which will be 0.005. It means that this totally will be 0.995. So this number comes 0.99, which is this area, plus this area, which is 0.005. It will be 0.995. So if I use inverse norm, 0.995, and the mu is 0 and standard deviation is 1, I can calculate the corresponding z star. So if I use the calculator, it will be second inverse norm. When I have the inverse norm here, area is 0.995 and mu 0 sigma 1. So it is 2.5758. If I round it, 2.576. So it will be my critical value, 2.576. So the margin of error is equal to 2.576 times 0.11 times 0.89 divided by 10,000. Since the margin of error we say plus minus, so I should say that here I can put it plus minus. So my result is, could it be E? Let me check. I think result is E. And something extra, where we use the margin of error to construct the confidence interval. For the confidence interval, it's not in this question, but you can see somewhere else. Since I am using here the p-value, so p-value plus minus margin of error will create for me an interval. So this interval is called confidence interval. Okay? Good. Do I have another question? Yes, one more question, I think. A politician wants to know what percentage of the voters support her position on the issue on first busing for integration. What size? What size means N. What size water sample should be obtained? So sample size should be obtained to determine 90% confidence. So confidence level is 90%. This is given to support level to within 4. So within 4 means it's a keyword within. It's a margin of error. So margin of error is 4%, means 0.04. Okay? Good. Now what can I do? I can say that margin of error is equal to critical z value times, let's say, standard error. For the standard error, since the sigma or the sampling standard deviation is not given, I should use the maximum one. But let me write first of all, let me read. Apple wants to know percentage, okay? So standard error of, let's say, P. I can say that this could be maximum 0.5 over root n. If you remember, we already seen in the classroom when I was explaining this, there was a table when p-value is 0.1, 0.2, 0.3 till 0.9. The maximum standard error occurs with this. For that reason, we say that margin of error within, it says 0.04 is equal to Z star, which is by using the confidence interval, we will decide this. So it was 90%. So this area is 90%, which is 0.90. So in two tails, we will have 5% and 5%. So totally then this will be 90 and 5, 95%, 0.95. So inverse norm, when I use 0.95, and mu is 0, sigma is 1. Let me calculate 0.95 inverse norm, right? So it will be 0.95, mu and sigma same, no change. It will be 1.6448. So I can say that 1.645, if I round it, 1.645. 1.645 approximately. So this is my Z star. So 1.645 times 0.5 over square root of n. So if I change the position, 1.645 times 0.5. So I have taken square root of n this side and 0.04 this side. So it will be approximately, calculators we should use. Where is the calculator? Here, 1 second. When I use the calculator, so here I have to say that 1.645 multiplied by 0.5 divided by 0.04, it is equal to 20.5625. So 20.5625. But I need the n. In order to find the n, I will take the square of this result. I will square the result. So n will be approximately the square of my result. So I can say that the answer to the power of, where is it here? Squaring the answer, which gives me 422.8. So 422.8. So I need 422.8 voters. So of course, this is the number of people who is supporting, who is voting. It means that I have to round this up. It will be 423, which is here the answer is C. This is and.